This will show you how to collect data from these graphical analysis files. What we're trying to do is find the acceleration of these different masses. So my example here, box plus 200 grams, we're going to label that the big side because that's the side that's being dropped. You can see that in the video. But that box plus 200 gram video is right here, and you can see it's box plus 200 grams. Big means the big side. When it says small, that means the small side of the box. It's the thin side of the box. Like imagine package boxes you're going to see in this video. It's got 3 sides to it. If I just slow that down, I might need to do this using the gear settings. Pick a slow playback speed. Let me just pause it here. You can see there's a large side of the box, so that's the large side, or the big side face down. The medium side would be this piece of the box that's facing us, and the small side would be the one facing to the left or to the right. Okay. So you can look at those videos if you want. The video itself isn't super important to this investigation, but the data is, and you can grab the data from this GA file. So number 4, if you just read this along, this is the procedure I'm doing. We're going to collect the data using the Graphical Analysis app. From step 3, it tells you how to get that. To use a Graphical Analysis file, click on the link, then click the Google Drive's download button. So if I look at the box plus 200 grams, and click on that GA file, click on this link, let it load. And up here, there's a little download button. So this is all kind of garbage looking to us, but it's telling us what the graph's all about. We want Graphical Analysis to open that file. So download. You see it down here. It should download in Google Chrome. And just click on that. When you click on that, it should bring up your Graphical Analysis app with the data in there. Okay, now what's next? We're going to look at the velocity time graph at the bottom of the screen. We're going to select data points on the straight diagonal line and apply linear fit. And the slope of this linear fit is the acceleration that we're going to try to record there. Alright, so here's the bottom velocity time graph. You can ignore the top. The top shows you the position over time. So you can see that the slope is getting steeper and steeper. That means the velocity is getting steeper, getting greater. Velocity is increasing. But if we look at the velocity time graph, the slope of that graph is the acceleration rate. So the instructions say to look at the straight diagonal line. Now if you look down here, this stuff doesn't exactly look like a straight line. That might not be dependable data. So we're going to look at the straight diagonal piece, that portion of it, because it's linear, and then go to Graph Tools, apply a curve fit, make sure it's linear, it should be, and we'll look at that slope there, negative 9.328. So that would be the acceleration of the 200 gram box with the big side down, negative 9.328. Now we can drop the negative, that just means that it's falling downward. I can type in negative 9.328 is like 328 is like 33. So I'll just round it to 9.33. And like I said, you can drop the negative because it's just the downward acceleration. Negative means it's downward. And that's all you need to record. Okay, so that's one example of how to do that. Just going to bring up one more GA file. I'm not going to pull the point for you, but just go through that process one more time. Download. We'll open it up. This is the 100 gram big side. Sometimes it takes a moment to open up. All right, if you run into this where it's having a little issue, try closing out the old one. You don't need to save the changes. You don't need to save the picture. Just try closing out that old one and try it again. I think graphical analysis can be a little buggy like that. Let's see if this one works. There it goes. Now this one, I want to show you this one because it's a little wavy in here. If you look at that whole set of data, though, it seems to be sort of continuous. This little area in here might be a little buggy, but I'm just going to select that whole thing since it's more or less in a line and apply a curve fit to that. So that one should work out pretty well. If you see the data down here is, if you're like, oh, it's kind of going below the line, you can go back and select less of the line and see if that line looks better to you. So that line looks like it fits the data a lot better. So I might go with that result rather than the whole thing. So that's about it. I hope this is helpful.